And here is the previously promised part 2 to comparing linear functions. So this is real life situations, right? Slope. Slope means rate of change. So it could also mean rate of pay. The earnings Y in dollars of a nighttime employee working X hours are represented by the linear function Y equals 7.5X plus 30. The table below shows the earnings of a daytime employee. So we have two different people, right? We have a nighttime employee who's getting this equation, and then we have a daytime employee who is getting this table of earnings. So what we've got to do is find out, how do they compare? That's kind of the point of this. How do these two people compare? Write an equation for the daytime employee. So the daytime employee, we've got to figure out how much they're making per hour. So $12.50 plus another $12.50 plus another $12.50 plus another $12.50. This person's making $12.50 an hour. So we're going to have Y equals 12.5x. And if we go back to 0, if they work 0 hours, it makes sense that they're earning $0. So we don't have to put plus 0, but this is going to be a direct variation. What is the rate of change for the nighttime employee? So the nighttime employee is getting Y equals 7.5x, meaning that they are getting $7.50 per hour, where the daytime employee is getting $12.50 per hour. Who has the higher hourly wage? That's clearly the person working during the day. $12.50 is greater than $7.50. This person's getting more per hour. If we want to compare them using a graph, we can put both of their earnings, on a graph together. So let's say the daytime employee does not have any plus anything. They're starting at 0, and they're getting $12.50. And let's see, it's just a little tricky because they aren't like perfect. Anyway, it's about that. So that's going to be the daytime employee. And then the nighttime employee starts with $30. They have a different starting value, but then they're only making $7.50 an hour. So I'm going to go 2 hours, $15, 2 hours, $15, 2 hours, $15, and so on. Interpret the graph. So what happens is around the 6-hour mark, they are making the same. So if they both work a 6-hour shift, they're both coming out with about the same paycheck. So we would say after 6 hours, the night employee starts making less. Do you notice that the black line for the night shift is below the red line now? So if they're working less than 6 hours, you'll notice that the night shift one is higher. So less than 6 hours, night shift earns more. And that's because of that initial $30 sort of, bonus maybe. All right, then we've got, you are controlling an unmanned aerial vehicle, also called a UAV, for surveillance. The table shows the height Y. Oh, let me see if I can get this focused before I start reading the whole thing. Pause for dramatic effect. There's no dramatic effect. I just can't get it to focus. You're controlling an unmanned aerial vehicle, UAV, for surveillance. The table shows the height Y in thousands of feet of the UAV X minutes after you start its descent from cruising altitude. So cruising altitude means it's way up high in the sky. At 0 minutes, it's at 65,000 feet. After 10 minutes, it's down to 60,000. After 20 minutes, it's down to 55, and so on. So they've actually given us the y-intercept, which is great. The 0.65, that's our y-intercept. That's our b value if we need an equation. The other thing it's saying is, write a linear function, write an equation. So we are also going to need the slope. Now, slope, not terrible because we have coordinates, so we can easily use the slope formula, y2 minus y1 over x2 minus x1. We can pick whichever two coordinates we want. I'm going to pick 1060 And I'm going to pick 30, 50 because everything ends with zeros, and I like that. X1, Y1, X2, Y2. And so when I go to find my slope, I'm going to have 50 take away 60 over 30 take away 10. I see a lot of negatives in my future, but that's okay. Negative 10 over 20. Negative divided by a positive, it stays negative, but lowest terms would be negative 1/2. So it's going to be y equals negative 1/2 x plus 65. Remember, we had the y-intercept from the table. Interpret the slope and the y-intercept. So what's happening here is it is decreasing, right? It's going down. And so it is decreasing by half, right? Negative 1/2. All right, get the focus going here. Wow, for a while I wasn't having a problem with it. Now all of a sudden I am again. I'm going to look up here and say every 10 minutes I lose 5,000 feet. Okay, so the change in y, right, it's a negative 1. Now remember, that's in thousands of feet, so negative 1,000 every 2 minutes. I could use that. I can also use that it's a decrease of 10,000 every 20 minutes or 5,000 every 10 minutes. According to the slope, right, it's the change in y. Y was height in thousands of feet, so minus 1,000. So decreasing 1,000 feet every, and then the 2 on the bottom is 2 minutes. So that would be my slope, and the y-intercept of 65,000 is what they described as cruising altitude. Or you could say starting height. Now that we've got an equation, it's really easy to find anything else that we need. Find the height of the UAV when you stop the descent after 1 hour. Now remember, the data was not in hours. The data in the table was in minutes. So instead of 1 hour, we're going to need to talk about 60 minutes. So we would say y equals 1/2 x plus 65. So we're going to look at after 60, it's a negative 1/2, my bad, times 60 plus 65. So that is negative 30 plus 65. Y equals 35. So after, it's a word problem, after 60 minutes, the height is 35,000 feet. Remember, it was being measured in thousands of feet.